out here to do a little trick to show you the relationship between productivity and costs. I want to recall a diagram that we spent a lot of time developing a little while ago. That was the total product curve. Remember, the total product curve shows you the relationship between the amount of labor your firm hires and the number of television sets you produce in a week. For instance, if you hire 2 workers, you'll be able to produce, according to the numbers we've been using, you'll be able to produce 10 television sets a week. If you hire 3 workers, then you'll be able to produce 30 television sets a week. That's your productivity. Now, think about this diagram viewed from the other direction. Suppose you ask yourself, how much will it cost my firm to produce 2 television sets? Sorry, so how much will it cost my firm to produce 10 television sets in a week? So instead of starting on the horizontal axis and going up to the total product curve, we're starting on the vertical axis and going over to the curve. We're saying, if we want to produce 10 television sets a week, how much are we going to have to hire? How much labor will we have to hire to make that happen? And the answer is, we're going to have to hire 2 workers. If we want to, however, increase our output up to 30 television sets a week, going over to the curve, we're going to have to hire 3 workers. Now think about this for a minute. Once you know how many workers you have to hire, you know how much it's going to cost you in labor expense. Remember, those 2 workers cost you $1,000 each for a total of $2,000. If you want to make 30 television sets a week, you've got to hire 3 workers. That's going to cost you 3 times $1,000 or $3,000 a week. The point I'm making here is that you can use the information in the total product curve to derive your costs. Only you're just reading the curve in a different way. Rather than starting with the number of workers and finding their product, you're starting with the product you want to produce and figuring out the number of workers that you'll need. This is exactly the information that we're looking for when we draw the variable cost curve. Only the axes are reversed. Instead of putting product on the vertical axis and labor on the horizontal axis, the way we do in our product curve, we flip things around. We put the total amount of output on the horizontal axis, and not just labor, but its cost on the vertical axis. Let me show you how to turn a product curve into a cost curve. Start with our product curve, and the first thing you want to do is flip the axes around. So I'm going to pick up my product curve like this. I'm going to pick it up and flip it over and lay it right here on my cost graph. Notice what I have now is a kind of inverse or mirror image of my original curve. Now, if I want to produce 10 television sets in a week, I know that I have to hire 2 workers, and I multiply those 2 workers by $1,000, and I'll get my variable cost. So in order to turn a product curve into a cost curve, you need 2 steps of geometry. The first step is take your product curve and reverse the axes, taking the curve with it. So we've just flipped the curve over and put the axes, the horizontal axis on the vertical and the vertical axis on the horizontal. The second step is you take this curve and you stretch it upwards by multiplying it by the wage. Each of these points represents a number of workers that you'll need. Now multiply that by $1,000 a week and it becomes your labor bill. So what I do is I take this curve and stretch it upwards and I get the variable cost curve that I drew a moment ago. And it looks like this. Notice this variable cost curve has the same shape as my inverted total product curve. It's just stretched upwards because I multiplied all of these numbers by the wage of $1,000. Now that's kind of a cool little trick. And if you want to try this trick at home, you're welcome to. I always like to draw my total product curve and then hold it up to the light, look at it through my paper and see its inverse. It's a neat way, a neat geometrical way of making it clear to you that cost and productivity are inversely or reciprocally related. It's because we're changing the axes and stretching the curve. There's the relationship.